Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am Bronwyn Slate.
If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You're always welcome to join me live through the Zoom link, which is available both for me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 2 until 3 in the afternoon. And we are now in our 9th and final week of our 9-week course. You definitely should know what you need to submit by now, but as always, just to remind you, the support questions, the ones with the little pencil icon, are not for marking. These are practice problems. So you decide which ones and how many to do. If you're understanding a concept, feel free to skip questions. You do what's best for you. If you need more practice, let me know and I can send you more. The answers are at the back of your booklets, so please check your work to make sure you're on the right track. The key questions are the ones with the little key icon, and these are the ones to submit for marking. So please do all of these questions, showing all of your work, your steps, and your thinking. This way I can understand what it is that you understand, and if you're struggling with anything, I can give you part marks and figure out how I can support you to understand. So how do you submit your work for marking? Well, there's 3 ways. The first way is to scan and send your work in electronically. If you have a device, a smart device, you can either scan it through an Apple device with the Notes app, or Android devices have a Google Drive app. These are free apps that generally come with these devices and are fairly straightforward to scan. If you'd like to learn how to scan your work to make your files slightly smaller and easier to manage, I have tech tutorials on my YouTube channel, which will walk you through step-by-step how to do this. Then you can send it to me through email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our location at 74 Front Street, with a bright red building next to the post office, and we have a small white mailbox next to our side entrance. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732, or toll-free fax to 1-800-463-7852. Sometimes when things get faxed here, they get lost in the shuffle. I'm not sure exactly how, but it's always a good idea when you send a fax. If students decide to send a fax, that's fine. Just send me an email or call me or something to let me know that you've sent it, so that we make sure that we find it. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. So you can find me on Facebook and subscribe to my YouTube channel, and then you'll get notifications every time I upload one of our videos. All of our radio Zoom classes are recorded, and I post them to YouTube shortly after airing. Also on my YouTube channel, there are short videos that explain common errors and confusing concepts. So this is a really good place to go if you are struggling with something and you need a little bit of support and you can't get a hold of me, it's outside of my working hours or something like that. It's a good place to go first before doing a general online search, just because it narrows things down already. Math is a really visual subject, so I strongly encourage you to access the videos, either joining me live through Zoom, though you may not talk to me, that's fine. Just watching is totally fine. Or watching the replays on YouTube is really going to set you up for the most success. If you can't access either of those because you don't have reliable internet or something like that, let me know and I'm happy to send you a copy of the videos so you get the full experience. All right, if you have any questions or concerns, please contact me. My email address is bronwyn.slate@nnec.on.ca. My Facebook, again, is B. Slate Wahsa. Call me at the office at 807-737-1488, extension 2209, or toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m. So please get in contact if you need support.
Today we are reviewing Unit 3. Let's first activate our brain with some mental math. We know that I'm not a fan of the mad minutes that many of us experienced in elementary school. They didn't actually teach us anything for the most part. They just force us to memorize things, but not necessarily understand what's going on. And so instead of doing that, we work on developing strategies that help us understand what's going on and that we can apply to various situations. Today's question is 16 times 25. And we're going to use a strategy of breaking factors into smaller factors. So we are going to look at, so 16 times 25 isn't a fact that I know, but if I say, okay, well, 16 is 10 plus 6. So if I want to do that times 25, then I can do 10 times 25, which is 250. That one is something that I can do. It's 6 times 25. And 6 times 25, well, 4 times 25 is 100, because I know that 4 quarters makes $1. And so if I have 6 quarters, that's $1.50. So that's 150. So then altogether, if I add 250 plus 150, I'm going to get 400. So 16 times 25 is equal to 400 by breaking up into those smaller factors that made it easier to multiply. All right, so first we're going to talk about what the final assessment is and what to expect. So even though I've spoken throughout the course about needing to be prepared for an exam, with COVID-19, we are not expecting students to do exams. It's just not possible for students to get to learning centers and be supervised for an exam. It's not realistic. So we're doing a culminating assignment this year instead. So that will still include all of the 20 lessons. So it's still going to cover all of the material and from the entire course. So it still does everything, even though it's a culminating and not an exam. But it's open book. So you have access to your assignments, to your YouTube videos that I've made, as well as anything else that you find that might be useful. Try a booklet with the instructions in and the help that's in those. And then also you can use the online tools like Desmos to use a calculator or a graphing calculator, or the virtual manipulatives like algebra tiles or the probability stuff, if that would be helpful for you. So you can use any of those resources and any other resources that you might want to do your culminating assignment, which wouldn't be available to you for an exam. It will not be timed, but it will have a deadline just in terms of giving you a rough idea of when I expect it to be completed, just so that it's not ambiguous and open forever, just probably around 2 weeks or so to get the work done so that you can finish your course. If you are hoping to do this closer to the end of June, we need to have all of our marks in earlier than the end of June. So the end of May, beginning of June is the last time that we can do our culminating. So you really need to be getting your work in before that. Structure will likely be unfamiliar as it isn't an exam. So it's going to be different than your IEL booklet questions where it's like, here's the question and you do the computation. It's going to be a little bit more creative and more of the application and thinking of an inquiry type assignment opposed to just computation based, as it being an culminating project means that it needs to be a little bit more involved in something that you uniquely have to think about instead of just copying down steps. You'll still be able to do it, it'll be fine. All right, so let's review our Unit 3 today, starting with Lesson 11, which was trigonometric ratios. All right, so trigonometry, this is where we talked about sine, cosine, and tangent. And the key for the entirety of Unit 3 is that your calculator must be in degrees. In order for your calculator to do the calculations the way we want them to, it has to be in degrees. So the top of your calculator needs to say DEG. It needs to be in degrees. If it says RAD or GRAD, then it's not going to give you the right answers. So then you need to find the DRG G button and press it until it says degrees, DEG. If you're having that issue, get in contact with me and we will figure it out, but it has to be in degrees. But for trigonometry, labeling your right angle triangle is essential in order to know what your ratios are going to be. So you have to have a right angle triangle for sine, cosine, and tangent for the primary trigonometric ratios. And then you have to know where your reference angle is so that you can then find your opposite side, which is across from your reference angle, your adjacent side, which is next to your reference angle, and then your hypotenuse, which is across from your right angle. So then we use SOHCAHTOA if that's helpful, or remembering that sine of your angle is equal to opposite over hypotenuse, cosine of your angle is equal to adjacent over hypotenuse, and tan of your angle is equal to opposite over adjacent. Then you can solve for an unknown side or solve for an unknown angle using the inverse function. So when you're solving for an unknown angle, you're dividing your ratios, then you ran to at least 4 decimal points so that you have enough information to get an accurate result. And then you need to use your calculator button. So this is the second function of sine, cosine, and tan. And it looks like sine inverse, which is sine to the exponent -1, or cosine to the exponent -1, or tan to the exponent -1. That's what what the inverse functions look like, which is what you need when you are finding an angle. So it's important to remember how to figure out which ratio to use. That's sort of the key element when you have a right angle triangle. So we have a few steps that can help you figure that out. So first step is to confirm that it's a right angle triangle. So with primary trigonometry, it has to be a right angle triangle. Otherwise, we can't use these ratios. These ratios are not true. Then you need to label your sides of your triangle. So find your reference angle, and then you are going to find your opposite side, your adjacent side, and then your hypotenuse side. Doesn't matter, you don't have to do in those order, but you find your sides and you label them. And for step 3, you identify what information you know and what you're solving for. So in this example that we have on the screen, we see that we are looking for our adjacent. That's where we have a variable. We know our opposite, it's 48, and we know our reference angle B, which is 36. So those are the 3 pieces of information that we know and are solving for. So we can ignore the other parts, so it's not useful. We don't need to find them. And then we choose a ratio. So we know that sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. When we look, we know our opposite and we're finding our adjacent. That means that we're going to be using tan. So that's going to be the ratio that is going to be able to solve for that. So that's the steps that you need to take every time you're doing a primary trigonometry question. You don't have to write them all out like I've written on the screen, but those are the steps that you should be doing just to make sure that you're on the right track. All right, so let's do some practice. So solve for the unknown side or angle. So we have 1A, we have a triangle, or right angle triangle, and our reference angle is 62 degrees. So let's call that angle A. Then our side opposite is X, and our hypotenuse, which is across from our right angle, is 34. So I can see that my adjacent doesn't have any information there. I don't need that to solve for my opposite. So opposite over hypotenuse, I remember, is sine. So sine A is equal to opposite over hypotenuse. So then sine of 62 is equal to X over 34. So then 34 times sine 62 is equal to X. And so then we're going to use our calculator, and we do 34 times sine of 62, and that equals 30.02. We're just going to say 30. Generally, it's a good rule of thumb to do whatever is the same in the question. So here we have rounded to whole numbers. We don't have any decimals, so we can just do the same thing. 30 equals X. So there we go. All right, question B. Again, right angle triangle. And so we have a reference angle of B. So it's indicating B is our angle. And then we have opposite, which is 43, and adjacent to our reference angle is 36. We don't know our reference angle B though. So we're going to find that. So because I have opposite over opposite and adjacent, that's going to be tan. So tan of B is equal to opposite over adjacent, which is equal to 43 over 36. So tan B is equal to, and let's get our calculator, and 43 divided by 36 is equal to 1.1944. So tan B equals 1.944. I did that right? Yes. So we have rounded it to 4 decimal places, and then we can find that angle B is equal to tan inverse of 1.1944. Sorry, squeezing it in there. You can write tan inverse on both sides, or you can just, this is sort of a shorthand way to do it. So then angle B is equal to, and we should do tan inverse of 1.1944, which is equal to 50 degrees. So angle B is equal to 50 degrees. All right, part C, we have a right angle triangle where we have a reference angle C of 14 degrees. And then the opposite we don't know. The adjacent is 13. And the hypotenuse is T, which is what we're looking for. So because we have adjacent and hypotenuse, we're looking for sine is going to be our trig ratio that's going to be helpful. So cos C is equal to adjacent over hypotenuse. So then cos of 14 equals 13 over T. So that's my hypotenuse. Then to solve for T, I need to multiply both sides by T because it needs to be on the top. It can't be on the bottom. So T cos 14 equals 13. I multiply both sides by T. T cancels off on the one side. And then T is equal to 13 divided by cos 14. So then T is equal to, with our Desmos calculator or your own calculator, we have 13 divided by cos 14, which is equal to 13.3, so 13. So T equals 13 as well, which can happen. Okay, and that's how you do your primary trigonometry questions. All right, lesson 12, law of sines. So with the sine law, or the law of sines, we have a triangle that is not a right angle triangle. So first we need to label our triangle, and a reminder that our vertices are capital letters and our sides are lowercase letters, and they are opposite each other to match. So this is really important in order to know which numbers and to go in the right places. So capitals on the vertices, smalls on the sides, and the opposites match. Again, calculator must be in degrees. So use the sine law. Again, this is not a right angle triangle. So we use it when we know two angles and a side, or we know two sides and an angle opposite one of the known sides. So technically we can do this if it's a right angle triangle. It's just more work that we need to do. So if we know that particular information, then we use the sine law. And the sine law, we have two formulas, which are really the exact same thing, just organized in different ways. And both versions will work in either situation. You just do the one that is going to make your life easier. So if you have angles, if you're looking for the angle, if you're solving for angle, then I encourage you to use the sine A over little a equals sine B over little b equals sine C over little c, because then you're solving for your angle is already on the top of your ratio. So that's going to be easier to solve for. If you're solving for sides, you use the little a divided by sine A equals little b divided by sine B equals little c divided by sine C. Again, because your side length is on the top, that makes it easier to solve for. But either one can work in either situation. You just might need to do more algebra depending on which one you pick. Okay, so practice question number 2, solve for the unknown side. So we have a triangle. We don't have a right angle, so we can't use primary trigonometry. We have a triangle x, y, z. We see that angle x is 95. Little side x is unknown. Angle y is 38 degrees. And little side y is 15. So we have two angles and a side opposite one of the angles. So that means that we can use the sine law. So we're going to say that we're looking for a side. So that means that it's going to be easier if we do x over sine x equals y over sine y, because we're solving for a side. So then x is what we're solving for. Then over sine 95 is equal to y, which is 15 over sine 38. So then to solve for x, we're going to multiply both sides by sine 95 in order to get isolate for x. So then we have 15 times sine 95 divided by sine 38. Again, you could do the numbers, you could do the calculations first and then do the algebra. I like doing the algebra first because that means that I'm not going to have to round and rounding errors. But either way works. It's the same. You'll just be slightly off if you round first. So we had 15 times sine 95 divided by sine 38 equals 24. Wait, 3. So equals 24. So x equals 24. Okay. Number 3, solve for the unknown angle. So again, we have a triangle that is not a right angle triangle, triangle ABC. We see that angle B, we have the symbol beta, which is a Greek symbol, which often we have for when we're doing trigonometry, is unknown, but side B is 28. Then angle C is 86, and side C is 54. So we're solving for an angle, which means we're going to use the version sine B over little b is equal to sine C over little c. So we're solving for an angle. So then sine beta is what our betas are unknown over 28 equals sine 86 over 54. And to isolate for sine beta, so we have sine beta equals 28, multiplying both sides by 28 to cancel it off. So 28 sine 86 divided by 54. And then we're going to put that into our Desmos. So we have 28 times sine 86 all divided by 54 is equal to 0.51725, so 0.5173. So we are rounding to 4 decimal places so that we get more of an exact answer. So sine beta equals 0. Yeah, it goes out of my head really, really quick. 5173. 5173. So then to solve for angle beta is equal to sine inverse of 0.5173. So angle beta equals, do this on my calculator. So find sine inverse of 0.5173, which is 31 degrees. So angle B is 31 degrees. Okay. All right. Lesson 13, law of cosines. All right, so for cosine law, we use this when we know two sides and the contained angle. So we have an example on the screen of triangle TUV, and we see that we know angle 72 at V, and we know side U, which is 61, and we know side T, which is 24. So because we know the two sides and the angle that's contained, the angle between those two sides, we can use the sine law to find the third side. Or we know all three sides, then we can figure out one of the angles. That's the other way we can use a cosine law. Again, calculator must be in degrees. I'm going to keep reminding you. So which formula do we use? As always, both versions work in all situations. Just one will make your life a little bit easier than the other, depending on the situation. So if you're looking for sides, if you're know a contained angle and two sides and you're looking for a side, then we use the form c squared equals a squared plus b squared minus 2ab times cos c. And that's going to solve for your side, your unknown side. Or if you're looking for your angle, then use the version of cos c equals a squared plus b squared minus c squared, all divided by 2ab. Again, these are exactly the same thing. It's just that we've rearranged the done the algebra before we put the numbers in, which might make your life easier. All right, so let's do a practice problem. Number 4, solve for the unknown side. So we have a triangle QRS. We see that angle R is 56. We see that side S is 48. We see that side Q is 39, and we're looking for side R. So we have a contained angle. We have the angle between two sides that we know, and so we can use the cosine law. We're looking for a side, so we're going to use this version of R squared equals S squared plus Q squared minus 2SQ cos R. How I remember this with my different variables is that you don't have to do it this way. You can label them A, B, and C. That's totally fine. But R squared is the side that I'm looking for. So I know that R is the angle that I'm going to need to have it. And then therefore the other two go into the other two spots. That's just how I remember it. You also can look it up. You don't have to memorize it. Look it up if you need to. All right, so R squared equals 48 squared plus 39 squared minus 2 times 48 times 39 times cos of 56. And then again, you can do them separately and write them down. I am just going to do it all on my calculator in one go. Works best for me that way. Also saves us a little bit of time. 48 squared plus 39 squared minus 2 times 48 times 39 times cos of 56 equals 1731.38. 1731.38. So R squared equals 1731.38. So 1731.38. I do that right? Yes, just like to check. Okay, so then now we need to take the square root of both sides because that's what R squared is equal to. So we take the square root of 1731.38, and therefore R is equal to, so the square root on our calculator, 1731.38 equals to 41.6, so 42. So our R is equal to 42. There we go. Great. All right, practice question number 5. Solve the unknown angle. So here we have a triangle MNP, and we see that we know we're indicating we have the Greek letter alpha at angle M, so that's the angle that we're looking for. And we can see that little m side M is 46, side P is 61, inside n is 24. So we know that we're trying to solve for angle M. So that means that we're going to use the cosine law for angles. So cos of M is equal to n squared plus p squared minus m squared, all divided by 2np. And how I remember this is that I'm looking for cos M, so that's my angle. So I know I'm going to be subtracting my little m, the side opposite my angle that I'm looking for. And then I know that only shows up once, and my other two sides show up twice. Then they're added together and squared, and then we're divided by. You need to figure out, if you're going to try to memorize it, you need to figure out how to remember it best for you. Or again, you look it up. So cos of alpha, you don't have to use the funky symbols, but I just thought I'd mix it up. I'm really bad at drawing alphas. It's a very sad looking fish. Is equal to 24 squared plus 61 squared minus 46 squared, all divided by 2 times 24 times 61. Again, you can do it in parts or you can do it all together. I like to do this part all together and then do the cos inverse is what works best for me. So 24 squared plus 61 squared minus 46 squared divided by, oh, see how when I just click divided by, it just divided by my 46. That's not what I want. I want the whole thing divided by. So I need to go back and correct that. This time when I highlighted them and then I click my divided by, now I'm dividing all of that by my 2 times 24 times 61. So that the calculator was just following the instructions that I gave it. And so it's really important to make sure that you give the instructions that you want. So that gives us 0.74487, so 0.7449. So equals 0.7449 cos of alpha. So that means that angle alpha is equal to cos inverse of 0.7449, and therefore angle alpha is equal to cos inverse on our calculator of 0.7449, which gives us 41.8, so 42 degrees. So angle alpha is 42 degrees. And that's how we solve for an angle using the cosine law. All right, lesson 14, trigonometry and problem solving. So with trigonometry and problem solving, this lesson, we are combining the information that we've just learned in the last 3 lessons and going to do some problem solving. So we need to apply which one, the situation which is best to use, which of those strategies is best to use. So first we need to identify our trigonometric ratio. So if we're going to use primary trigonometry, which is SOHCAHTOA, those ratios, we have to see, is our triangle a right angle triangle? If our triangle is a right angle triangle, then the best option is to use the SOHCAHTOA ratios because it's the simplest. Sine law, we use it when we know 2 angles and 1 side, or we know 2 sides and 1 angle, as long as the angle is opposite one of the known sides. Then we would use a cosine law if we know 2 sides and 1 contained angle, so the angle between those 2 sides, or we know all 3 sides. So depending on the situation, we're going to use these different strategies. We also have to remember the angle of elevation. So the angle of elevation is the angle straight out from sight level to the horizon and then up to an object. So we're looking up, that's the angle of elevation. And the angle of depression is when we're looking straight out to the horizon and then down to an object. And that is the angle of depression. So sometimes those come up in our word problems or in our situations. And so we need to know what we're actually doing when we're interpreting those problems. All right, so number 6, the angle of elevation to the top of a mountain is 45 degrees. If I walk 100 meters further away from the angle, the angle of the elevation is 44 degrees. What is the height of the mountain to 1 decimal place? So I find with these questions, drawing a triangle, if they don't give us one, drawing an image really helps to visualize what's going on. So I'm going to draw myself a mountain. I'm going to do it green, pretending that it is summertime, which it is not here. So then I have my mountain. So I know for my person looking up, so my angle of elevation, so straight out and then up, is going to be 45 degrees. Then my person walks 100 meters and looks up and sees from there that angle is 44 degrees. So now I can figure out the height. I'm going to redraw my triangle without my lovely pictures, just so that it's easier for me to see. I'm going to copy it, but you don't have to do this, whatever, you figure out what works best for you. So if I'm looking for the height of my mountain, that means that I'm actually looking for, you know what, I'm going to make my triangle bigger. I'm not happy with it. Sometimes we make things too small just to try to save space, and that makes our lives more complicated. So reset. Okay, so I have my triangle. Again, it doesn't have to be perfect. As you can see, my triangles are never perfect. So I have one angle is 45 degrees. The other angle is 44 degrees. And between them is 100 meters. So I'm looking for the height of the mountain. So I'm not looking for the side lengths up the mountain. I'm looking for the height, which we would measure right up the middle, which would be perpendicular to the ground. That's how we figure out the height of the mountain. So from this information that I have, can I just figure out the height of the mountain in one step? So I have an angle, and my height is opposite my angle, and it's 9 degrees. So that would make me think that I want to use my primary trigonometry, but I don't know any side lengths for certain because that height falls somewhere on my 100 meters. I don't know where it falls. I can't assume that it's 50. Can't assume that it's halfway. I don't know that for certain. So that means that I can't assume that. So I need one of my side lengths on the mountain, like one of the hillsides sort of, to figure out in order to then figure out what my height is. So I'm going to say I'm going to find this side X, and then I'm going to use that to figure out what my height of my mountain is. So for step 1, I'm going to find X, which is one of my sides of my mountain. So if I look at that, okay, so I have 2 angles and a side. So that means that I can use the sine law to figure out my side X. X is across from 44 degrees, so that's great. But then my side length that I know of my triangle is 100 meters, and it's across from my angle that I don't know. So I need to figure out what that angle is. So that angle we use, so this is the kind of question that has a bunch of steps. So in a triangle, we know that we have 180 degrees. So we do 180, take away 45, take away 44 is equal to, well, 45 and 45 is 90, and that's half of 180. So if it was 45 and 45, it would be 90, but it's 44. So that means that it's 91 degrees. So this angle up here is 91 degrees. So now I know that's across from my 100, and so I can use that for my sine law. So I'm going to use the sine law. I'm looking for a side, so I'm actually going to use the version that has my side on the top, because that will make my life easier. So I'm looking for X, so X over the side opposite it, the angle opposite it is sine 44 is equal to 100 over sine 91. So x is equal to 100 times sine 44 divided by sine 91. All right, I'm going to use calculator to do this. So 100 times sine 44 divided by sine 91 gives us 69.47. So we're just going to say our length is 69. So x is equal to 69 meters. Okay, great. Now, does that answer the question? No, that does not tell us how high the mountain is. So that means we're still looking for this. But now we know that x is 69. So that means that we can use we can sort of imagine that we have this small right angle triangle in here that tells us the height. So we have 45 degrees and we have 69 and we're looking for the height. So our height is our opposite. We know our hypotenuse and we know our angle. So opposite of hypotenuse is sine. So steps 2, we're going to use the sine ratio of sine of 45 degrees is equal to opposite over hypotenuse. So sine of 45 degrees is equal to h over 69. And so h is equal to 69 times sine 45. So using our calculator, 69 times sine 45 is equal to 48.79, so 49 meters. So our height is 49 meters. So now we answer the question, what is the height of the mountain to one decimal place? I rounded it off, so let's go back to look what our calculator said, 49.79, so it's 48.79, which is 48.8. So good to check your question again. So the height of the mountain is 48.8 meters tall. Okay, and that's the question. So it had 2 steps. So it's important to know that sometimes you're going to have multiple steps. All right, practice question number 7. A park is enclosed by 3 paths, so it makes a triangular shape. If the path lengths are 145 meters, 230 meters, and 190 meters, what is the area of the park? Okay, so again, let's draw our situation. So we know that we have 3 paths that are certain lengths, and they connect to make our park be a triangle. We're going to label our paths, 145, 230, and 190. It's okay when you draw it, it's not to exact, it's totally fine. This is just sort of a visualization. And what is the area of the park? So again, to find the area of a park, we need to find the height, because we need, in order to find the area of a triangle, we need to know the height so that we can do base times height divided by 2 to find our area. So we know our 3 sides, which means using the cosine law, we can find one of our angles. So I'm going to pick one of my angles that is not where my height is, because that's what I would need. So I'm going to pick this angle. I'm just going to call it angle C, and that's what we're going to look for. So step 1 is find angle C. So cos of C, because we're finding the angles, is equal to a squared plus b squared minus c squared, all divided by 2ab. So remembering that C is 145, and then A and B are my other 2 sides. Doesn't matter which one's which. So then cos of C is equal to 230 squared plus 190 squared minus 145 squared, all divided by 2 times 230 times 190. So cos of C is equal to, get our calculator out. So we have 230 squared plus 190 squared minus 145 squared, all divided by 2 times 230 times 190, which is equal to 0.7777. So cos C is equal to 0.7777. So angle C is equal to cos inverse of 0.7777. So we do that on your calculator. Cos inverse of 0.7777, which is 38.9, so 39 degrees. So angle C is equal to 39 degrees. So now we know that this is 39 degrees, and we can then figure out our height because we know one of our sides. So very same. So step 2 is the same idea as what we did in the last question, is we say, okay, we have a reference angle is 39 degrees. We're looking for our height, which is across from us, which is our opposite, and we know our hypotenuse. So we're going to use our sine ratio. So sine of 39 is equal to h over 190. And so 190 times sine of 39 is going to equal h. So 190 times sine of 39 is equal to 119.57, so 119.6. So h is 119.6 equals h. So then have we solved the question? No, we haven't yet. This one's even further because we need to find the area. So step 3 is find the area. So the area of a triangle is equal to base times height divided by 2. Well, in this case, our base is 230. That's, if we look at our triangle, our height is perpendicular to that. So 230 times 119.6, which is the height that we found, divided by 2. So one last time with our calculator, we have 230 times 119.6, all divided by 2 is equal to 13,754. 13,754 meters squared. So that is the size of a park. This area is 13,754 meters squared. And that's how we find it. Okay. All right, lesson 15, creating nets. So with creating nets in this lesson, remember that a net is a flat version of a 3D object that can be folded to recreate that object. A pattern is a flat version of that 3D object where the parts are separated and need to be reattached. And a plan is a flat version of a 3D object that shows the front, the side, and the top views so that it can be reconstructed. So our question here is number 8, which of the following nets can be folded into a cube? So a cube is a 6-sided, they're all squares, all contained. So it's a 3-dimensional version of a square, right? All of our faces are the same. So we have A, B, C, D, E, and F. And we have to guess which ones, if we can visualize, if we were to fold this, which one is going to be a cube. So when I look at A, I have 5 cube squares in a row and one that sticks out. So to me, that tells me, well, there's no way that I can fold this so that I get a top and a bottom. So I don't think that A cannot be a cube. B, when I look at B, I have 3 squares in a row and then move over 1 and 3 squares in a row again. And so I'm trying to figure out, is there any way that I can fold this? Well, because how I visualize it is I want to flip this one. I really want to use my hands. It's really, really hard to do this on a screen. If I flip this one, if I fold along here, I'm going to have them, they're going to be perpendicular, which means that this one can fold over here and this one can fold over here. And this one's going to fold here and this one's going to fold and close a box. So I think B does make a net. C, I have 4 squares in a row and then I have 2 on the same side, 2 that stick out on the top. They're separated by 1 square. So I think that if I fold these around, this is going to give me a square shape, like a cube shape along the side, but these 2 are going to fold on top of each other and I'm still going to have a hole in my base. So C, I say, is not a cube. And then D, I just looked at this and it looks like a little dinosaur to me, actually. So I have 2 and then 3 and then 1 in the middle. It's really hard to describe these. So again, so this one, I think if I flip this one here, that's going to create a bottom. If I flip this one here, that's going to create a top. And then I can fold this one in and fold this one in. Those are the sides. And then I feel like I could flip that one down and create the back. So I think D does work. Then E, I have a 2 vertically and then a shift down like stairs and then 2 vertically and then a long tail of another 2. So looking at this and I say, okay, well, if I flip this one, if I fold along this edge here, then that's gonna, and then fold this one down, that's gonna create a top. And then this is, I can fold up and it's gonna create a bottom. And then this one I think can fold here and then fold back. So I think E can be a net. And then for a cube, or is it net for a cube? And then for this last one, I have like a sort of elongated Z sort of, go backwards, a backward Z. So I have 4 all together, squares together, and the top and the bottom both have 1 sticking out on opposite sides. So if I were to fold here and fold here and fold here, I would end up with 4 sides. But then I don't know, I'm feeling like that doesn't actually work. No, that works. And then I fold this one down and fold this one up. I don't know if I'm going to say maybe is, but I'm not sure. This one doesn't feel great to me. So the other thing that you can do, and then is that I will link this, is that you can go to our virtual manipulatives, and I'll link this in the show notes so that you can play with them. And so this one I actually have created so that we can, I want to move my screen. So that you can actually play with these ones. So you highlight them, you have to highlight them all and fold the net, and then you can turn them. And you can see for A, I said it was not a net and I'm correct. So you can do that for all of them. I'm just going to quickly check this last one that I wasn't sure. I fold it and it does make a cube. So that last one does make a cube, which makes me wonder if maybe one of the other ones I got was wrong, that I thought were going to be a cube and wasn't. This one. E, I was wrong, does not make a cube. So that's a great way to play. You can go into there and play. All right, this is, we have come to the end of our lesson today. So we've reviewed Unit 3 today. So go in and play with those nets if you want to play with that a little bit more. If you have any questions, as always, get in touch with me the usual ways by calling and leaving a message for me at the main line or sending me an email or a Facebook message. All of our lessons are on YouTube, so you can go back and review them if you need to. Thank you so much for joining me today. Good luck with your review, and miigwech.